Hi, this is Hilal. In this video on Mathematical Economics series, we will solve a numerical on a market model. The question is given a market model for a single commodity, QD is equal to A minus BP, where QD is the quantity demanded and P is the price. Similarly, QS is given as minus C plus DP, where QS is the quantity supplied and P is the price. And here A, B, C, D are the parameters given as A is greater than 0, B is also greater than 0, and C and D are also greater than 0. We are told to find what will be the change in the equilibrium price when the intercept of the demand curve changes. So we have to see the effect of change in the intercept of the demand curve. That is, what will happen if this A changes. First of all, we know that market is in equilibrium when demand is equal to supply. Okay, that means we equate these two equations, that is A minus BP is equal to minus C plus DP. Now transposing this will become A plus C is equal to DP DP. Transposing this minus BP, so this will become plus BP here, or we can write A plus C is equal to, now taking P as common, so we are here with B and D, so I will write B plus D. That means our equilibrium price is A plus C, so this will go on the division here in the denominator, so this will become B plus D. B plus D. So this is the equilibrium price. Now we have to find what will be the change in the equilibrium price when the intercept of the demand curve changes. We have to see what will happen if this A changes. That means here it is treated as endogenous variable. So we will differentiate this P, partially differentiate this price with respect to the variable which is here A. So dP by dA will give us the change in the price when the intercept of demand curve changes. So this is equal to, here we can see it is the quotient rule. We will use the quotient rule of the differentiation. That is, first we write B plus D and D by D A, and differentiate A plus C with respect to A minus this A plus C and D by D A, and then take this B plus D. So I will show the quotient rule, and here we have B plus D whole square. I will show here the quotient rule says if we are given a function like this, f x is equal to h of x divided by g of x, that means the derivative of this with respect to x, we write it as f dash x is equal to, we take the denominator which is the function which is in the denominator g x, and take derivative of hx minus, we write this h of x and take derivative of g of x. G dash x means g of differentiating the g of x function, and g of x ka whole square. So this is the quotient rule of the differentiation, which is not used frequently in economics. Now solving this, here we have here B plus D, so this is same B plus D. Now the derivative of A is 1, we write here 1 times 1. The derivative of C is 0 here because it's constant. Here A, so I will write here minus A plus C times the derivative of b plus d. These are all treated as constant, so derivative will be here 0, divided by b plus d whole square, which comes out to be b plus d. Now minus a plus c times 0 is 0, so we have to do nothing with this very term here, and we have b plus d whole square. When cancelling 1b plus d, 1 plus d, so we are here with 1 divided by b plus d. So the change in the price when the equilibrium price, rather when there is change in the intercept of the demand curve, is given by 1 divided by b plus d. Another question says, what will be the change in the slope of the demand curve? That is, what will be the change in the equilibrium price when the slope of the demand curve changes. So we have calculated the equilibrium price. Now we have to differentiate with respect to the slope of the demand curve, which is b. That means dp divided by db will give us the resulting change. So using the quotient rule, we write b plus d, first b plus d, and take derivative with respect to b of this a plus c minus a plus c, and take derivative of this denominator, that is b plus d, and divide it by b plus d whole square. Okay, since we are differentiating with respect to b here, so we will see here it is b plus d will remain same. Now here a and c, these are constants. The derivative of a constant, as we know, is 0, so it is times 0 minus a plus c. Now here we have this b, the derivative of b is 1 and derivative of d is 0, so we get here 1, so it is here 1 divided by b plus d whole square. Now this is 0, we can write it as minus a plus c divided by b plus d whole square. So this is the change in the equilibrium price when the slope of the demand curve changes. Another question says, what will be the change in the equilibrium price when the intercept of the supply curve changes? Now in this case we are told what will be the change in the equilibrium price when the intercept, that is this c, changes. Okay, we will see the change. So this is dp divided by dc. That means differentiating this equation with respect to c, rather partially differentiating. So using the old quotient rule, we write first this b plus d, and take derivative of with respect to c of this a plus c minus a plus c, and take derivative with respect to c of b plus d whole divided by b plus d whole square. Now with respect to c we have to differentiate. Here we are with this b plus d. Okay, now derivative of a is 0, derivative of c is 1, so here it is 1 multiplied by 1 minus a plus c, the derivative of these two constants is here 0, so this is 0, and we get here b plus d whole square. Now solving again, this term is here 0, so we get b plus d divided by b plus d whole square, and cancelling one term we will get 1 divided by b plus d is the right answer. That means the change in the equilibrium price when the slope changes is given by 1 divided by b plus d. Again, the question says what will be the change in the equilibrium price when the slope of the supply curve changes. We have to see what will be the change in the equilibrium price when this d changes, this parameter d changes. So differentiating with respect to d, so that is dp divided by dc, d is equal to, using the same quotient rule method, we write b plus d first, b plus d, and take derivative with respect to d of a plus c minus a plus c, and take derivative of this d by d by dd of this b plus d divided by b plus d whole square. Okay, now here we can see we are differentiating with respect to d here. So first we will write b plus d is times a plus c. These are the constants, so here it is 0 minus a plus c. Derivative of d is here 1. The derivative of b is 0, so it is 1 here, times 1 divided by b plus d whole square. So here we get this term is here 0, so we will get here minus a plus c divided by b plus d whole square. So the change dp divided by dd, that is change in the equilibrium price with respect to the change in the slope of the supply curve, is given by this very term. Okay, I hope I make myself clear. Thank you.